Alright, so this video is going to be part 3 of finding the radius and interval of convergence. So we start off with the sum from n equals 1 to infinity of -1 to the n plus 1 times x minus 7 raised to the n over n times 7 to the n, and we want to find the radius and interval of convergence. Here is our step-by-step process. First, is it something that we can make into a geometric or p-series? Obviously that's not going to happen here because we have this n here, so we're not going to be able to make this into a geometric series like we did in the last video. Okay, so what we're going to have to do is use ratio or root test. Here it's going to be ratio test. Okay, so we can take the limit as n approaches infinity. Remember, this is going to be a sub n plus 1, okay, a sub n plus 1 over a sub n, and that's going to be in an absolute value sign. Okay, so that is going to be, well, a sub n plus 1. That's a -1 to the n plus 2 times x minus 7 to the n plus 1 over n plus 1 times 7 to the n plus 1. That's going to be over just your a sub n up here, -1 to the n plus 1 times x minus 7 to the n over n7 to the n. Okay, now let's make this a little bit prettier by separating this into groups. And also, these negative ones, just let them go. They don't mean anything because we have these absolute values here, and that will get rid of those negative ones anyway. So we get the limit as n approaches infinity of, well, like I said, the negative ones go away. We're gonna get x minus 7 to the n plus 1 over x minus 7 to the n times, it's going to be n over n plus 1. Alright, and then lastly we have our 7 to the n over 7 to the n plus 1. Okay, so now we can simplify this a little bit. Remember, since these are all being multiplied, we can take the limit separately of each, okay, and that helps for this n over n plus 1, because we can see that the limit of that, since we can just divide everything here by n. You can do that if you want. You can use L'Hopital. If the, considering that this would be a separate limit, the limit of this is just going to be 1. Now, you have a 7 to the n over 7 to the n plus 1. That's just going to be a 1 over 7. Okay? And here, x minus 7 to the n plus 1 over x minus 7 to the n. That's going to give you just an x minus 7. So, the result of this limit, we're going to get just x minus 7 from here. Okay, that's what we're getting. And then over here, we get an over 7. And that, the absolute value of that, needs to be less than 1 for this power series to be convergent. Now, what we can do, get rid of these absolute values and put a greater than -1 here. Okay, so we do with absolute values. Now, we can multiply by 7 on each side, or on every side, and what we get is -7 is less than x minus 7 is less than 7. We can add 7 to everything, and we get 0 is less than x is less than 14, and that's what we're going to start out with for our interval of convergence. Okay, so we can write up here, the interval is going to be from 0 to 14. Not sure if we're including the endpoints yet. We'll figure that out in step 3. But we also need to find the radius of convergence. Now, if this interval is from 0 to 14, from 0 to 14, okay, the center of this is 7. Okay, so from the center out to one of these endpoints, that's supposed to be a curly bracket. Doesn't look like it. From the center to one of these endpoints is 7. Okay, that's the radius of convergence. Okay, so get your radius to be 7. All right, now we need to check the endpoints for the interval, and we're going to do that by plugging in each endpoint into this power series and seeing what happens. Let's do that now. We get, plugging in 0, we get the sum from n equals 1 to infinity of -1 to the n plus 1. We put a 0 times, or 0 minus 7 we get negative 7 to the n. That's going to be over n times 7 to the n. Okay, now we can simplify this, or at least we're going to be able to simplify this because of what we're about to do here. We get a negative 1 to the n plus 1 times a negative 1 to the n times 7 to the n. Okay, we're able to break that negative 7 to the n up to negative 1 to the n and 7 to the n. And I explained why in greater depth in the last video. Okay, so if you're confused on why that's able to be a thing, definitely go check that out. Now, the 7 to the n's, they cancel out, and we're just left with a negative 1 to the n plus 1 times negative 1 to the n over n. All right, now, what is this really saying? Well, this negative 1 to the n plus 1 means that all even terms are going to be negative, and this negative 1 to the n means that all odd terms are going to be negative. So every single term is going to be negative. That's what that's saying. Now, if every single term is going to be negative, well, then that means that this is just the sum from 1 to infinity of negative 1 over n. Okay, it's the same thing. We can say that. Now, this, we know that's going to be divergent by the test for, well, not by the, this is a divergent because it's a p-series. There you go. That's it. So, the harmonic series, right, the harmonic series, doesn't matter that it's negative, whatever, it's still going to be divergent. Okay, now we can look at the other endpoint, because we know we're not going to include 0 here. So the other endpoint, we're going to have the sum from n equals 1 to infinity of negative 1 to the n plus 1 times 7 now to the n, okay, because we plug in 14, we get 14 minus 7, that's going to be 7, and that's why we end up getting a 7 to the n over here. Now we're going to have this over n times 7 to the n, and the 7 to the n's go away. We're left with the sum from n equals 1 to infinity of negative 1 to the n plus 1 over n. And we know that this is the alternating harmonic series, and that is convergent by the alternating series test. Okay? It's nice when you see a series pop up that you're familiar with. Okay? So that's convergent. What that means is that our interval is going to change to include 14 as an endpoint. Okay? However, 0 is not going to be included because it was divergent when we plugged in 0. Okay, so that's not part of our interval of convergence. Okay, so there's your interval, there's your radius. That's it for this problem, and that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for radius and interval of convergence, in the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.